Welcome to the discussion and thank you for always joining us. We are presenting a question that was done in KCSE 1997, paper 2, question number 22, statistics 2. And the question we have reads, the table below shows the frequency distribution of masses of 50 newborn calves in a ranch. We have the mass in kilograms and the frequency, which represents the number of calves. The first part of the question, on the grid provided, draw a cumulative frequency graph for the data. For us to draw the cumulative frequency curve, we plot the cumulative frequency against the upper class limits. And therefore, I'm going to begin by introducing the cumulative frequency column. And for us to get the CF, we start with the first frequency, which is 2. Then we take 2 plus 3, we get 5. 5 plus 10, you get 15. 15 plus 14, you get 29. 29 plus 13, you get 42. 42 plus 6, you get 48. And finally, 48 plus 2, you get 50. After getting the cumulative frequency column, we need the upper class limits. For the upper class between 15 to 18, the upper will be 18.5. Then the second one will be 22.5, 26.5, 30.5, 34.5, 38.5, and lastly 42.5. After doing that, now we go to the table. We go to the grid. We are drawing the cumulative frequency curve. Also known as an ogive. On the y-axis, we are going to have the cumulative frequency. So on the x-axis, we are going to have upper class limits. Which represents the mass in kilograms. We also have the y-axis, which is our cumulative frequency. Now we can mark our points on the grid. We are going to begin from 0. Then we are going on the y-axis, we are going to use 1 centimeter to 5 units. And therefore, since the highest frequency is 50, we are going to go with 5, 5. So it is 5, 10, 15, 20, 25, 30, 35, 40, 45, and lastly we have 50. We can go up to 55 because graphs are never exact. After that, we move now on the x-axis where we have the upper class limits. The first one is 18.5. The second one is 22.5. The next one is 26.5. The next one is 30.5. After 30.5, we have 34.5. After 34.5, we have 38.5. After 38.5, we have 42.5. After 42.5, next we are going to have 46.5. And from here now, once we have done that, we go and start plotting. When we have 18.5, the frequency is 2. At 18.5, we have 2. 2 is here. At 22.5, we have 3. At this point, At 26.5, that is, we have 5, sorry. At 26.5, we have 15 at this point. At 30.5, we have 29. 29 is at this point. At 34.5, we have 42. 40 is here, 41, 42 is here. At 38.5, we have 48. 48 is here before 50. And when it is 42.5, it is 50 at this point. Once we have done that, we can now join all the plotted points so that we can form our ogive. That is our cumulative frequency curve. That is our cumulative frequency curve. We can label it as an ogive. After that, now we can move and answer the questions that we are supposed to answer. We have been told to use our cumulative frequency curve to estimate the median. In this case now, the median will be found at the mark that is going to divide the data halfway. So the total is 50. You divide by 2, you get the 25th mark is what is going to have to give us the median. So you go to the cumulative frequency curve where we have 25. Then you draw a broken line towards the curve. You draw another broken line downwards so that we can be able to read off the point where our median lies. And at this point, you can see that our median is going to be around 29, around 29.5 there. So our median is going to be around 29, and that becomes the answer to this particular question. Let me call it part A. Then Roman 2, we are supposed to find the probability that a curve picked at random is having a mass of between 25 kilograms and 28 kilograms. So what we are going to do is go to the upper class limits and pick a point along the x-axis. So you go to the x-axis, locate a point where we have 25. That is 22, 23, 24, 25 is at this point. Just go up. Then from there move towards the y-axis, and at 25, that is B, at the 25th mark, the value we have there is 11, and at 28th mark, we are going to have 28 is this is 26, 27, 28. 28 is here, so we can move up and then read off the mass with the number we have on the y-axis, and this one is going to be exactly 20. And therefore now for us to get the probability, it becomes very easy. So at this point, at the 25th mark, the probability of the 25th mark will be, the reading is 11. So we are going to have 11 out of 50. And at 28th mark, that is probability at 28, the number we have is 20 out of 50. And therefore for now, for us to get the probability that the mass lies between 25 and 28 will be equal to, the probability at 28 is 20, The probability at 28 is 20 out of 50. We minus 11 out of 50, and this one is going to give us 9 out of 50 as the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, you click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.